Hello students, we're going to start a new topic or chapter. Topic 3 is called transformations. Does anyone remember anything about transformations from Math 8 or algebra last year? It's kind of an important concept and it keeps coming back over and over again in math. Because we can take shapes and move them around the coordinate plane and we can get different things. One of the things we can do, I'm just going to take the letter R. If I have the letter R, that could be a shape. It's made of some lines and a curve. I can move it and I can draw it over here up and to the right. And if it's exactly the same size and shape, that's a translation. Another thing I can do with the letter R is I can reflect it. So I can have a line of reflection and then I can draw it backwards. Another thing I can do with the letter R is rotate it. So maybe I'll spin it this way. We'll spin it this way. Okay, now it looks like that. Now, if these were exactly the same size and shape, that would be doing this to an object keeps it the same size and shape. There's one more that you may have learned about, but we're not going to cover that in this chapter. All right, so the first one is reflections. Here's some different types of reflections. You can see your reflection in a mirror. In physics, we talk a lot about reflection and the reflection of light. If it hits a mirror at a certain angle, it's going to bounce off the mirror at the reflected angle, and those angles are going to be congruent. That's kind of interesting. And in nature, we can see a shape. Maybe we could think of this as a triangle. This is called Mount Rainier. And you can see down here, it has a reflection in this beautiful lake down here. The geometry definition for a reflection looks really complicated, but it's a lot like the lake and the Mount Rainier. So a reflection is a transformation. It's one of the 4 types of transformations that reflects each point in the pre-image across a line of reflection. So if this is your mountain and this is the lake, this would be the reflection. Reflection has a couple properties. If the point of reflection is on the line itself, then it doesn't move. The point and its reflection are the same point. Point and its image are the same point. If I wanted to find where B, the image of B is gonna match up, I could grab a phone. Phones are mirrors. You have the screen off, then you can put it right along so if you have your phone right now, you can grab it, make sure the screen is off, and put your phone right along line M, that dashed blue line, and you can actually see the reflection in the phone. Okay, so the line of reflection is halfway. It's almost like this is the midpoint of a line segment, B prime. A shortcut way that your textbook uses to talk about reflections is with a capital R. And this would say the reflection over line M of triangle ABC is going to yield or give us triangle A prime, B prime, C prime. And A prime, B prime, C prime are the images of A, B, and C. It is a rigid motion, so the original triangle is going to be exactly the same size and shape. All the angles are the same, all the line segments are the same length. Okay, so how would I do this? Well, again, if you have a phone or a mirror with a shiny surface, you can put your mirror right on line L and you can look in it and you can see the reflection. I'm gonna just kind of eyeball this one. So I'm gonna say, how far is it from here to the line? It's about that far. So I have to go about that far to the other side. And notice that this is perpendicular. So that's gonna be H prime right there. Okay, if I wanna find G prime, I have to go straight to the line with a perpendicular. And then I have to go that far out the other side. So if I went this far, I have to go the same far out to here. This and this would be the same length. Okay, and then F, same idea. I have to go perpendicular right to the line of reflection, and then I gotta go out that far. That's a lot farther. So I'm gonna go woo, and I have to go woo out to here. So F was the furthest away from the line, and F prime is the furthest away from the line. H prime is here, this was G prime, and this was F prime. And if I sketch it, it should look like the same size and shape. And F was the furthest away, so F prime is the furthest away. H is the closest to the line, so H prime will be the closest to the line. That's how you would sketch it. And again, check it by looking in a mirror. Here's one thing that we like to do. We have triangle A, B, C, and we know where the points are. And the question is, what are the coordinates of the vertices, the points at the corners of the triangle after this reflection? So I'm going to graph it. You can use graphing tools. There's a really cool program called GeoGebra that I want you guys to play around with this chapter. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, there's point A. This is the x-axis. Point B is 1, -2 right here. And point C is over here at -3, -4. It's kind of a long, kind of an acute triangle, kind of tall, maybe almost isosceles. And we want to flip this over the x-axis. So we're going to put our mirror right horizontal. And we're going to look in the mirror and see where the points land. So point A is all the way over here. This is -5, 6. And we're going to flip it over the x-axis. So it's going all the way to the x-axis, and then it's flipping over to the other side. So it's over at -5, +6, and now it's going to be at -5, -6. 1, 2, 3, 4, 5, 6. So the new A prime is way over there. This is -5, -6. All right, C, well, let's do B next. B, to get to the x-axis, is 2 units. So if I want to find the new B, I have to go 2 units across the other way. So the new B is going to be over here. So the old B was 1, -2. The new B is 1, +2. That's interesting. Now, what do we think about the new C? Well, this is point C right here. And I'm going to go straight up to the x-axis. It takes me 4 steps to go straight up. So I have to go 1, 2, 3, 4 on the other side. And the new C is going to be right there. And the coordinates of the new C are -3, 4. And I could draw it. I'm going to draw it like, oh, it's so messy. Okay. They're kind of overlapping each other because part of it was in the top of the graph and part of it was in the bottom. So another way to do that is say that A, B, and C. A was -5, 6, and A prime is -5, -6. See if you can see the pattern. B was 1, negative 2. B prime is 1, 2. And C was negative 3, negative 4. And C prime is negative 3, 4. You see the pattern? If I'm thinking of a number that a point that has an A and a B, any point, what's the image gonna land at? Think about that. What's staying the same and what's changing? Okay, there's a really good program called GeoGebra that has some good tools. We can check that out. So here is, I created it in GeoGebra, and you should play around with it. And then what I'm going to do is I'm going to use GeoGebra to make it do the reflection. And this time we're going to do the reflection across the y-axis. I wonder if I can pull it up quickly. Oh, you can't see that. All right, fail. I'm just going to stick with this. Okay, so A is at negative 5, 6, all the way over here. And if I'm trying to have this be my line of reflection, it's 1, 2, 3, 4, 5 away from that line. So I have to go 1, 2, 3, 4, 5 across the other side. So the new A is out here. A prime is 5, 6. See the pattern? Are you thinking about it? Okay. B was at 1, negative 2. And I'm trying to reflect it over the y-axis, so it's going to end up 1 away on the other side. So B prime, its reflection is over here. B prime is negative 1, negative 2. And C was 1, 2, 3 away from the y-axis, so I have to go 1, 2, 3 on the other side. C was originally at negative 3, negative 4. And now C is at 3, negative 4. So can you think what would happen to some point AB if we wanted it to be a reflection across the y-axis? What stays the same and what changes? It's also really important to know that this new shape, the new triangle, is exactly the same size and shape as the original. Okay. Ooh, what is a general rule for reflecting a point across the x-axis? So we could do this one. We would have, now this is going to be a quadrilateral. And you have a point at 0, 3. You have a point at 2, 4. You have a point at 4, 2. And you have a point at negative 2, 0. This is kind of a almost a trapezoid, maybe. That's a cool shape. Okay, and what do we want to do for it? We want to reflect it over the x-axis. So I don't really know what it's going to look like. I could be more careful, but it's going to look something like, it's going to be attached right there. This is 3, 1, 2, 3. It's going to be kind of 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 1, 2. Looks something like that. It's a little funky. Okay. So you could do it that way, or you can just list it out, because I think we're starting to see the pattern. So 0, 3 is point F. And where is F prime? F prime is going to be also 0, but it's going to flip down to negative 3 because I'm doing a reflection across the x-axis. G is 2, 4. G prime is going to be 2, negative 4. H is 4, 2. H prime is going to be 4, negative 2. You can see it. 4, negative 2 right here. And then j is negative 2 comma 0. J prime, also negative 2 comma 0. Okay, so here's what we've been talking about. When a point xy on the coordinate is reflected across the x-axis, its image is the x stays the same and the y becomes its opposite. Let's see if that works. Is the x the same in this column and this column? Yes. Is the y the opposite? Yes. So this is xy. And this is still x. See, all the x's are the same, but the y is the opposite of the one we had. So when it was 3, it became negative 3. When it was 4, it became negative 4. When it was 2, it became negative 2. What's the opposite of 0? 0. Yeah. And it also works if you reflect over the y-axis. So the y-axis, you can take the coordinates, you keep the y coordinate the same, and the x becomes its opposite. So we already did that for the x-axis. So now we can just do it for the y-axis. So what do we say? For the y-axis, we're going to keep the y the same. And we're going to take the opposite of x. The opposite of 0 is 0. And keep the y the same and take the opposite of the x. There's another point. We're going to keep the y the same. And we're going to take the opposite of the x. It's really fun to play with these, with GeoGebra. Okay, so we're going to keep the y the same. What's the opposite of negative 2? Positive 2. Well, that's how you would do that kind of problem. So here's a summary. A reflection is a transformation that reflects each point in the preimage across a line of reflection. So if it's on the line, the reflection is also on the line. If it's far from the line, you have to go all the way that far out the other side. Here's the way that we can write it. The reflection across line M of point A is equal A prime. Okay, that's it for today. Practice.